Yeah, I'm comfortable in C++.
Uh, okay. So your preference is C plus. Okay. So it's your turn to be the interviewer. So it means you are going to do this work. I mean, you are going to
Yeah, it's my
solve
turn
this. Okay.
to solve the question.
Okay. Okay.
Okay. Let me give me 1 minute to read the question. Smallest substring of all characters given an array of unique characters ARR and a string str. Implement a function get shortest unique substring that finds the smallest substring of str containing all the characters in the array. Return empty string if such a string does not exist. Come up with an asymptotic optimal solution and analyze the time response. And then constraints provided array.length less than equal to 30 and string str.length less than equal to 500.
Mm-hmm.
Okay, so I have been provided an array of characters which is unique. All the characters in the array are unique, and I have been
That is
provided
correct.
as what?
That's correct. That's correct.
Yeah,
The
and
array is actually unique characters.
yeah,
Mm-hmm.
and I have been provided a string of the character.
Mm-hmm. Mm-hmm. That's
I
correct.
so
So what
this
you've got to do is you have to return,
you have to return a substring from the str which
right?
contains all the characters which
Mm-hmm.
contains all the characters in the array, like which
That is
those
correct.
the characters present in the substring must be present in the array.
Correct.
Yeah.
Correct. And it should be not just only the substring, it should be the smallest substring.
Okay. So it's smallest
Okay.
substring. Yes. Thank you
Yeah,
for that.
smallest. Okay. Yeah. Just to clarify, so let's say in the example that is provided, right? X, Y, Y, Z. Okay, if
Yeah,
you
X
look
Y
at the
Z.
first four, it satisfies X, Y, Y, Z. It contains all the characters,
Yeah.
but that doesn't necessarily have to be the smallest,
Hmm.
right? So you need
I
to
got it.
figure out the smallest of this, which our output here is ZYX,
Yeah, that's
which
right.
is correct, and that's the smallest possible. That's a difference. Okay.
Yeah, got it. So I'm thinking to try all the possible cases, like all the substrings, and I'll check
Mhm.
in those substring that if this substring contains all the characters present in the array, then I will choose the smallest among all the substring.
That's like a brute force
Yeah. So
method,
yeah,
right?
that takes O of n squared to do that. Order of n squared to do that.
Okay. Okay. Is there any other better way
Let
that
me
you could
think.
do?
Let me think about any other solution.
I mean, what you're doing is you are actually iterating the first loop, and then you are going to check the inner loop for each
Yeah.
of them. Is that
Yeah.
right?
Yeah.
So, can you actually think uh, um, slightly? Yeah. So, I mean, what is that you have to?
What do
What is it you have to maintain here? Like, are you able
I
to
have
think about any? Uh-huh.
I have to maintain like the frequency of each characters, like each character present in the array. If all is
Mm-hmm.
one, then that
Mm-hmm.
if all is greater than one, greater than equal to one, then that means all
Uh-huh.
the characters present in the array is present in that
Mm-hmm.
substring.
Mm-hmm.
That I have to maintain.
Okay.
So
And what would you do for that?
mm, I have to like think like a window, maintain like I have to see in a window. If I if I'm at like ith index and I'm seeing from the ith to j index. Like suppose the starting is ith index and the ending is jth index. If this is the substring, and if that is present in the, if all the characters of the array present in that substring, then I'll check for the other substring, mm, by decreasing its size,
Okay.
which I'm thinking of like sliding window approach
Um,
or two pointer approach.
okay.
So,
So,
so what?
I mean, you are going in. You could, yes, you could. I mean, you could actually use like two indices. That's what he
Yeah,
meant.
yeah, yeah.
Start and like an end or whatever, like a sliding window, and efficiently like traverse the array, right? So yeah,
Okay,
you
if
could. You
I'm,
could.
let me
Mm-hmm.
explain through this test cases.
Yeah.
So if I am starting from I brawler 0 and j is
Mm-hmm.
equal to 0,
Mm-hmm.
then I will iterate through this array, iterate through this
Mm-hmm.
string, and I
Mm.
will like maintain a, I'll maintain a, I'll maintain a frequency, or I can keep like
How do you do
keep
that?
the hash using an ordered map. I
Okay.
can keep, or I can maintain a
Okay.
vector of array,
Okay.
like
Okay.
vector of the array of 30, size 30.
Uh-huh.
So I will mark each of them that which is present on
What
the,
does it? Where did you come up with that number 30?
what?
You said 30, right?
Yeah, 30.
How did you come up with that number 30?
Yeah, that's given here, that the
Okay.
maximum
Okay.
length of the array
Okay.
is equal, less than equal to 30.
Okay. So you're going to.
Maintain a array which will like, in which I will
Okay.
keep if this character
Count.
present or not.
Basically count.
Like a visited array.
Sure. So you're basically maintaining the count in that array. That's what
Yeah,
I
yeah,
mean,
count
right?
of that
Int
element.
array. Okay. Okay.
So if I'm starting from 0 at 0, then I will check. I will check if I will check if where x is present, which I can do
Hmm.
using a hash value. Like I'll maintain x, if x, like I'll keep a hash value that x is present at 0, y is present at 1, z is present at 2, like that.
Yeah, the ASCII value you can say.
Yeah, yeah.
So say ASCII value minus the A
No, I'm not
is
talking
the
about
is
the
the
ASCII value.
index.
I'm talking about the, in like, which characters are present in this array. I don't have to check all the characters. I only have to check those characters which are present in the array. So I can keep
Correct.
I can keep all the values present in the array. Like I will make x as 0, y as 1, z as 2,
Okay.
which I will store. Let me explain you. I will make x as 0,
Okay.
y as 1.
This is in the array, right?
Yeah,
Okay.
z as 2. And here,
Okay.
if the size is 3, then I'll make array of size 3, which initially will be all 0. Okay.
Okay.
Thereafter, I will iterate through this string, and I will check
Hmm.
the first x is equal to, if I'll see the first x, so I'll find where x is present in the array. So it will give me 0. So I'll increase the count of the 0th index, that will become 1, and I'll
Okay.
increase the j value by 1,
Okay.
and I'll see if I'll see by iterating this through this array, that if all are one, all are like all the characters present or not. So if that will not be present, then I'll go further. So here it's all the is not present in the array.
So is array would work or a hash map you would need? Because
Yeah,
what I'm actually
I need a hash
understanding.
map.
Okay. Because you need to go to that particular key to get the count,
Yeah, yeah.
right?
Which
So you're explaining with an array. That's why I was actually.
this I will
Um,
keep in a hash map,
okay.
and
I
I'll,
see. I see.
yeah. And
Okay.
then after I will go to the next index, that will be 2, that will be the y. So I will also increase the second, the first index, count of the first
Okay.
index. Then after I'll go to the again y, then it will
Mm-hmm.
become 2, and
Mm-hmm.
after that it will become 1 at the third
Okay.
index. Yeah.
Okay.
So at this index I'll check if this is like, if this is means all the values of the array are present or not. Here all the values are present, so I will initialize a value that will keep my, that will minimize the answer. So I can make it like only 9, so that will be the minimize the answer. So here, if I found all the values of the correct, all the values of the array, then
Mhm.
I will like see the value, and like maximize, sorry, minimize the value with this j minus I plus 1. That means here I
Mhm.
found the first, here I found here I found
The
the substring.
first
Yeah,
possible
first
string.
substring that contains all
Substring.
the characters present in the
Mm-hmm.
array. And
Mm-hmm.
after that I will increase here, increase the I
Mm-hmm.
from here
Okay.
until I found all the characters, like all the characters present in the array. So here if I will increase the I, then I have to decrease the count of x. So x will become 0, and here when I will see that it's not present, like it's all the characters are not present, then then again I'll have to go through the j. So again I will increase the j by 1, that's 4, and it will add y, so it will become 3. Then again
Okay.
after going to next character, then it will increase the second z,
Mm-hmm.
and when I will go at the end, then it will become like this 1 3 2, and it will be like one 2
Okay.
3 4 5 6 7, and j will like
Okay.
7. So here I
Okay.
found one more substring, that is yz yx.
Okay.
So this will be
Okay.
like, this the size of this character 336 617. Yeah, the size of this substring is 7, so it will not be minimized because value was initially 4.
Right.
So value was
Right.
initially 4, and so it will
It will
like
remain
remain
four.
4. Yeah, it will remain 4.
Right. Uh-huh.
So
What
here,
you will do now?
here after doing this, I will increase I, and I will keep checking if it's possible or not, that by decreasing the window, if it's possible that all the characters are present in the smaller window, I will check for that. So if
But
I,
your I has already moved to 7, right?
no,
So
j is at the 7, I is not at the 7, I is the 1.
correct. I is at 2. We'll go to 2 now.
Yeah, I have to go to 2,
Um,
and it will
2.
decrease the count of y.
Correct.
So it will be, y will become 2. So again it's, I will check if it's smaller than this value or not. The value will remain
It is
same
not.
because yeah. So again I will
Right.
decrease, increase the I, so that will become 3. Here also I have to decrease the value of y, that will, so y will
Okay.
become 1, and again the value will remain same because
Z.
it's again 5 size substring of is of 5 size, so it will remain same. After that I'll again increase 3 to 4, so it will come here
Mm-hmm.
z.
So Z has gone.
Yeah,
So
z.
that becomes 1.
I mean, like,
That
okay,
becomes 1.
I have decreased more, one more y, because 4y was there. Sorry, sorry for that. Actually, there
No,
were
no,
four.
no. No, no,
There
no.
was,
1 only. It is 1.
no.
No, no, no.
I'm
Okay.
saying that I have decreased more y. Actually, there are four y from one to,
Okay.
yeah, yeah. So I've decreased one because I've only decreased two y and I have made it one. So
Okay.
it's, yeah.
Okay.
So after that, I will have to decrease
So
this.
Z will become 1. Z will become 1.
Z will become one. Yeah. So zero,
Okay.
1, 2, 3, 4. It will come on the 4. And again, why will it become 1 when I will come at this index? Because I have to decrease the count of y. But
Now it
still,
is less than. Now it is minimum.
yeah, now its value will
So,
be changed to 3, 4 to 3. So when I will
okay.
again further decrease it, then it will become by x. That means it's not all the character present in this array, like in this window. All the characters of
Okay.
array are not
What's
present in
the,
that window.
sure. What's the complexity of
Okay.
this?
Okay, let me think of the complexity. So actually, like I'm going j from, starting j from 0 to n minus 1. So like this, and I'm also doing increasing 0 to n minus 1. So if it will take O of, if I'm considering it of O of n, and it's
Mm-hmm.
also of O of n, so it's basically O of 2n. Like that means the order of n. Overall, it will
Yeah,
be order
order
of
of
n.
it's order of n.
Yeah,
That's what I mean,
yeah. So
right?
the time
You
complexity will be
drop the
order of n.
constants. Yeah,
But in
you are
but
doing
inside
hash.
that, I'm using the hash. So
Correct, correct.
so it
That's
will
what I
take
was about
order
to
of
ask.
n into the size of the array that is present. The array size, that means,
What that would be now
like, so it will be order of n into
into
if I am considering the size
m.
m, size of the array of as m. So this will be the time complexity, but it's given the very smaller because it's 30. M is less than equal to 30, so it will be very smaller. Or if
Right.
uh,
Hmm.
I'm also using extra space to store this value, so it will also take, the space will it
Well,
will take.
yeah. First let's actually finish off time complexity. So so every time when you loop in, you would
I'm
actually
checking the whole array
hash
that
map.
it's present or not.
You'll check the hash map, look at the count, and then decide whether what is if it is achieved, like all of them are non-zeros. That's the val possible val, and you'll
Yes,
check if that
yes,
is actually lesser than what is found, and you always pick the least of that. So okay, and the space complexity here is the hash map,
yeah, the hash map. That
right?
means the size, like
Hash map is
number of
additional.
characters present, the number of unique characters present in the array. That will be the
Uh-huh.
that will be
So
the space
order of
complexity.
order of
Order of
m,
m, yeah, order of m.
space complexity. Okay. Okay, let's actually um,
This is a time complexity. This is the space complexity.
so so the time complexity, can that be achieved? um, you have put order of n into m, right?
Yeah,
Can that be what you have to do for achieving n plus m?
plus 10.
Mm-hmm.
Okay.
This is slightly expensive, right?
Yeah, yeah.
um, but what is the way to
Let me think. So,
n plus m? Okay.
I'm getting. I'm keeping the values of 1%.
So um,
Yeah.
if there if
Yes.
one optimization, if do you have to care about a character if it doesn't exist in map?
Mm, if it doesn't exist in the array, the character present.
Correct.
Yeah. So if
Correct.
no, I don't have to care about those characters which is not present in the
Okay.
array.
Okay, so you can skip them, so which
Yeah.
means you won't actually need the iterating in the map as well
So
for those characters. You'll just pass it, right?
actually,
You'll
I'm
skip
not
it.
iterating all the map. Actually, I'm keeping the array, like visited array, for all the characters. Actually,
No,
I'm
it
keeping.
doesn't. So it doesn't, whether you're iterating map or iterating array. I mean,
So
from a time complexity perspective.
I'm iterating only with those characters which are present in the array. I'm not iterating for those characters which are not present in the array.
No, no, no. I'm not talking about this. So And this array, what you're talking about, is equivalent to the hash map. Is that right?
Yeah, yeah, that's equivalent to that.
Yeah.
Yeah, I can also
Yeah.
keep
So
like keep the
the
count like
m is the m iteration you are doing still. That's my point. For every n, you are
yeah,
doing m,
yeah,
right?
yeah. I'm doing
Yeah. Is there a way to optimize it? So first thing is, if that character doesn't exist in the map,
okay,
you
okay, got
won't
it,
need
got it,
that.
got it, got it. So like I don't I will not keep um I'll I'll not iterate the whole hash map. I'll just like
Hmm,
I'll just see the size of the map if it's like equal to the
hmm,
array size or not. If I'll
hmm.
keep as a hash map. For that I can for that firstly I will see all the characters present in the array and I'll like keep that in a unordered set or hashing, and I will iterate through the string and I will take only those characters which are present in this hash map. Let me explain it.
Okay.
So if I am iterating through this string, if I am iterating through this string, then
Hmm,
I can like give a map, and map will keep the like key and value as a pair. So it will keep like that, x as one, y is it two, like this. So if I have to remove this, then it will it will be removed from this map, and it will not I will not have to iterate through all the map. I will only see if this if all is present, like let me see. So if if all the characters uh, characters of the array present in this window, then the size of
hmm.
this map will become equal to the size of this hash map will be equal to the array dot size. So I will not
Right.
need to check for the whole like whole map. Like I will not need to iterate through the map. I'll only check if this if this if the size of this hash map is equal to the array dot size or not.
Hmm.
But during the inserting I will check if this character of this string is present or not, is present in array. Then only I will insert those characters in the like hash map. So then after I will not need to check I'll not need to check by iterating. So this will decrease the time complexity, like it the time complexity will become order of mm, order of n plus n. Yeah, it will become order of n only.
So what would you do? Can you elaborate it again?
Okay.
Um,
Actually, initially I have made another set where I was stored
all right.
all the characters which are present in this array,
Correct.
the unique characters. So
Right.
when I'm traversing and I make a hash map which will keep as a key and the key pair value.
Count.
Key will be the characters and the pair will be the count of the
Correct.
character.
Correct. Correct.
So if I will come inside this loop, then I'll check if this character character present in this string is present in that array or not. If that is present in the array, then I will insert that character inside this hash map. And each time I will have to only have to check if this hash map, the size of the hash map is equal to this array or not. Because I'm inserting only those characters which are present in the array. So if that
Okay.
hash map size of the hash map become equal to the array, that means all the characters present in that hash map.
But the see whether correct. That's correct. You can actually check if the array size. I mean hash map size and then the array size. Then it actually means every character is present. That's
Yeah,
fine. But the frequency that you are actually comparing,
yeah,
that will be. I mean 1, 2, and 1 doesn't necessarily have to, right? You based on
yeah,
the logic that you have.
yeah. So it will like increase or decrease. So when it will become zero during the removing, then I'll erase this character from this map as map.
Oh, you'll remove it. That's what I mean.
Yeah, 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 that means. So I'll
Okay,
erase
that's
it.
a change.
Yeah,
And then you are going to not iterate the map. You will just check the
yeah.
size
I'll
of the
just
map.
check the size, so it will like reduce the time complexity. I'll not have to iterate through the whole map.
Um, so looking into the size is an order of one. That's fine. And okay, um, okay, let's implement this. But we are like you don't have time. Like I mean, we are probably like few minutes. You can actually implement this quickly if
Okay.
possible, right?
Yeah.
Let's treat it like a real interview at that time, right?
Okay.
It's just like 30 minutes is what we were discussing. Okay, where are you typing? Okay.
So basically, I have declared a set that I'm sorted all the characters present in this array into the hash set, and I've implemented an hash map of character and int. So and I'm sliced I equal to 0, j equal to 0, and the answer. And I've find the size of the string. After that, I've iterated through inside this loop while j is less than n. So if this is present, okay. Should I explain you the approach? Check it. Or you got it? Hello?
Yeah, yeah, got it.
Do you get it? Or
Yeah,
should I explain it?
yeah, yeah. So you are actually increasing. I mean, you're comparing J,
Yeah, I'm
and
comparing J.
can you'll have to compare I as well, just to make sure, right?
No, I don't have to compare I because I is on the left side. So when J will like go on the right side. Like J will
No, no, no. What I
cross
meant
J.
is, sorry, no, I doesn't cross J.
No, I don't cross J. Yeah.
No, you have to make the check, right? No,
No, I don't
you'll
have
never
to.
cross.
No, I will never cross because if I will come in this while loop, then
Mm-hmm.
if the size will not equal to height of size, then it will not like go up, go forward. So I will not increase. That means I will not never
Okay.
like exceed the. So let me check
Okay.
it.
So this is a while loop. The first one is doing insert into the map. Okay, that's order of n. The next one will be order of n, and the map would be order of 1.
It's, it's like the total time complexity will be order of n plus order of n, not order of n into order of n.
Yeah, yeah, order of n is the total.
Yeah, yeah, the order of n is total.
Yeah.
So let me check it for the compilers. Right.
It says for first
Okay, okay.
argument. Which
I
line?
have to I have to include the header files of node.sit and header map, which I am using.
Uh, should automatically be there. Okay. Anyway,
What's not
what's
there?
the error? Let's see the error. Um,
Okay.
some conversion error. Hold on.
Sorry, sorry, sorry. Let- Actually, I have to return the string, not the size. So that,
Correct.
yeah, yeah, I got it.
Oh, you're not returning. Okay.
Why? Yeah. So answer is greater than this. J minus I plus 1. Answer is equal to J minus I plus 1. X equal to J. I is equal to J. So outside, I will make a string temp G20 initially, and I will do while x is less than equal to y, and I will insert this term is equal to str of x and x plus. Yeah, do you get it? So should I explain?
Yeah.
Actually,
Yeah.
I kept two
Got it.
pointers like x and y, like the
Mm-hmm.
starting the starting index of that substring and the index
Mm-hmm.
of that substring,
Mm-hmm.
which I returned at
You for
this point.
every match, every time when the map actually matches the size,
Yeah, no, no,
you're
no.
capturing the bounds. You're
Every
keeping
time
them.
every time when I find the smaller substring, then only like I'm changing that pointer.
But the ants that you actually have,
Yeah,
that is j minus. That's basically length is what you are actually capturing.
yeah. The length of
So
is x.
yeah,
Yeah,
yeah, that's fine. That's the one which is important. Yeah.
yeah. Let me run through the test cases.
Okay. One of them failed. Um,
It failed.
A. It's just only A, and the string is empty. You need to handle that.
Actually, I have to return the empty string when I haven't found anything, which I returned.
No, you returns null. Is it right? Or
Yeah, I've
you
returned
don't
empty
return?
string. I've returned empty string when I haven't found anything.
Okay. And you're returning empty string.
Yes.
It doesn't seem to be expected. Okay. Can you print what x and y?
Okay, 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 okay. Yeah, now it's like Actually, when I don't found anything, then x and y was like garbage value. That's why it's given like that.
Ah, okay. Okay, that makes sense. Okay.
So I have to check for the if.
The first is good. But you actually initialize -1. Is that right?
It's written 0. Yeah, yeah, yeah. So that's what I have to
Uh,
check, that if it must be greater than equal to 0, x greater than equal
okay.
to 0.
Okay. Perfect. Cool. Yeah, this is good. And the space complexity of this?
Let me
Time
see.
complexity is order of n.
Space
Space
complexity,
complexity.
I am using an unordered set, and I'm also using an unordered map, that is has set and has map. So all the characters present in the array, that is of size m, so it will be order of m's, that will
Where
be
are you
has.
using the unordered set?
Because I have to check that if this character, if some characters are not, if some characters are not
No, no, no.
present
Where are
in.
you using it?
Why?
Where are you using it?
You're asking why am I using
No, where are you? Where are you using the set?
unordered set?
The map, the map you're using, but the set where are you using?
On the line 13.
No, I understand you inserting this
Okay, okay, yeah.
in line
See on the
13.
line 24 and the line
Okay,
number
the
13.
count.
Yeah,
Okay, okay. So you are your unique values you are capturing in the set, and for every unique value, you are increasing
I'm only
the.
increasing the count of those characters which are present in the array. So I can't like iterate through whole the array to check for that. So just I kept a hash set of those characters, so I can check those in order of one.
So when you say map of that key plus plus, it will automatically increase the value, is it?
Yeah,
Okay.
it will directly increase the value. If it the
Okay.
value, if the key is not present, then it will
It,
generate that
it's like
value.
array. You are accessing like an array. Okay, that's
Yes,
fine.
yes, yes.
Okay, it's like operator plus plus overloaded.
So
Okay.
the space complexity of this will be order of m, the unordered set, and the unordered
Mhm.
map will also take same space like order of m, because I'm keeping only those values which are present
Correct.
in this array. So overall, it will be order of
And that
m.
array, and then the while loop would be order of n,
Yeah.
right? So it
Yes.
is n plus m.
What the
The overall time complexity will be n plus m.
yeah, that I'm talking about the space complexity. It will overall take order of m only.
No, the time complexity as well
Yeah, time
will
complexity is
be
like,
order of n plus m.
yeah, yeah, that will be like order of n. Overall will
Order
be
of n
order of,
plus m.
yeah, yeah,
N
yeah,
plus
n
m.
plus m. Yeah.
Yeah, the m is also like you iterating, right? No, that's fine. That's negligible. That's not a big deal. But this is good. Okay, sounds good. I think this is good. This is optimal solution. Great job. Yeah, it's good. So let's actually see if there is anything else that um, we covered. Yeah, I think we're good.
Okay, swap the rules.
Yeah, let's actually go to the next one. Let's see what I'm doing. So
Great.
I will have to see what I'm actually struggling good. Okay, let's see.
So
Uh, okay. Wow, this is actually tree problem. Nice. Okay. Cheapest cost. The car manufacturer Honda holds their distributed system in a form of a tree. The root is the company itself, and every node in the tree represents a car distributor that receives cars. Okay. The root is the company itself, and every node in the tree represents a core distributor that receives cores from the parent. Okay, ships them to the children nodes. Okay, basically the intermediates are distributors. Basically, okay. So and then the final nodes, the leaf nodes, are receivers. That's what it means. The leaf nodes are called dealerships. Okay, and that sell cars directly to consumers. In addition, every node holds an integer that is cost of the shipping a car. Okay, taking tree example. Okay, have a path of Honda's factory to a car dealership, which is the path from the root to the leaf, and it's called a sales path. The cost of the sales path is the sum of the cost for every node in the path. For example, okay, transaction sale 031, and then the value cost is part of the node here. Okay, so basically the value of the node is the cost at every one, which is the cost. And for example, the tree sales path is 03010 should be 13. Okay, Honda wishes to find the minimal sales path cost in its distribution tree given a node, root node, write a cheapest cost that calculates the minimal sales path cost in the tree. Implement your function in the most efficient manner and analyze its time and space complexities. For example, given a root node in a tree diagram, your function should return 7 since its minimal cost path direction. Okay. Um, I mean, from what I understood in the problem, in the tree that is actually shown here, for finding out the cost for each of this, I will have to do depth first search. As I do the depth first search, I compute the cost for each of them, and then I will pass a argument called as min cost or whatever. And as I actually compute the cost, I will compare the min cost, and if it is greater than the cost, then I will assign the min cost, and then I'll keep like floating around that min cost. So recursively, I'll keep calling it left and right, and then um, that path, whatever that minimum
There,
path,
there
is
can
what
be
I have to.
multiple children, so you should not like left or right. You have to iterate for all the children. Actually, it's not a
So
binary
for
tree.
that, it's not a binary tree. Oh, it's a general generic tree.
Yes, a generic.
Oh,
There
okay.
can be like array of children.
Oh, oh, okay, okay, okay. So, but the dealership. So the okay, I see. But still, I have to do a depth first search
Yeah.
for each of them, for each child until I reach the leaf. I have to do the depth first search. So there is no left and right child, but if
Hello. Hello.
are you not able to hear me?
Yeah. Now I will.
Okay, so no, it's not a binary tree, but it's a generic tree. So what I would do is, for every node, if it contains children, I'll call recursively that method, and all I have to do is keep track of the minimum cost, and then for each of them, I will compute whatever is minimum cost, like with that entire like recursively call it until I reach the leaf node. I will keep adding the cost, and then basically that min cost comparison would be after, because until I reach it, and then finally I will actually have always track of the min cost for each of the depth first search of each of the um, children, a child tree, subtree, and that I'm actually reading. Um, that's approach which I'm actually thinking. Okay, so I'll go here and then code that. Okay, so okay, so first this is, let's say, okay, and I'm going to possibly node and then int main cost. Okay, I'll pause here. That I'll call that when I do that because I have to recursively call it. And if node dot, is it like children? Yeah, node not equal to null first of all, right? And first of all, if node is null, first of all, here let's actually see that. Private void. Okay, if node equal to null, just return. Okay, I will not do anything here. Return. If node not equal to null, I don't need to check this because it's already checked already. So node is if node dot children not equal to null, basically there is some children existing.
Okay.
Then I have to basically call for each of them. I have to um, call that recursively because there could be multiple children, right? So what that means is for because it's an array, for node child children, that's an array, right? So node dot children, right? You'd basically call get minimum cost, sorry, get minimum cost of child comma min cost. Okay, so this will recursively call. Now what that means is for every time when you're done, um, you would actually here say if min cost, right? Min cost is I have to keep adding them. Hold on. For each of them, I have to keep adding the total cost, right? So should I return the cost? Keep on adding, recursively adding them, like plus plus. I have to keep adding the values. What that means is here, let's say return node dot cost plus
बोलो
um, have to do
क्या
so that it keeps adding the
क्या
value, right? And then
एक मिनट
let me think about it. How do I capture it? So for each of the node in this example, from 0 to 5, 5 to 1, it keeps adding, and then I actually kind of add the value, right? And add the value for each of them. So first it will come here, 5, it'll take 5, 3, 6. For 5, again, it'll check if his node has any children. It'll go to 1. That'll be called. Okay. So, and then now we need to add the cost at 5 and cost at 1. We need to add that and then compare against min cost. That's what we have to do. Now, min cost I can pass the minimal cost, like I mean the least integer that I can pass at first call when I'm calling it. So now I need to compare this with the value that is getting returned. Like iteratively, I'm adding it. Either I can add it here, or I can actually pass a value here, which is actually keep track of the values. I think if that's actually something that I can do, return, 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 return. So you keep returning, and then you have the value, and then when it is root, so now you don't compare it here. Okay, so um, mm, okay. So only if there is okay. So okay, okay. This is null, right? Like if it is not null. Okay. Now I have to do, because I have to do this computation only if it is equal to null. When I reach the leaf, that's when I have to actually do the comparison, min cost comparison. So what that means is I need to have the total cost that is computed till then, like until I reach the leaf node, and that would be this null basically. And if the node dot children is not equal to null, it means I reach that leaf node. Now, when I reach the leaf node, um, okay, return return the minimum of the cost. I can return the minimum of the cost, so which means minimum between min cost and the total aggregation value, um, that I can return. Okay, let me see, 5 and then 1, and when it is now comparing, it should be, let's say, like the value here is 5 and 6. 6 is the value, or what is it? Is it 6? How is the value associated here? Okay, 6 and 1, is it? Is it 6 and 1? Okay, I have a question here.
Yeah.
So 0, 5, 1, right? It's a 5, 1, or what is that value here? Here
Where
it's not visible for me. In the example, 0, 5, 4, is it?
054 on the left side.
4. Okay, okay. That I was actually reading it as 1. Okay. So okay, that's why it didn't get selected. So it'll be 0, 6, 1, that because that's a minimum value. Okay. So anyway, so basically this would actually keep on adding until we reach that, right? Until we reach that value. Now all I have to do is, how do I get that value? Get that 0, 5, 1. I would have reached here. One easiest way is, you could instead of this, you keep adding you have a running variable, variable here, which actually you return it, you have it as a variable. uh, okay, okay, so let's say I need to capture that value. I need to capture that as a variable somewhere, because I need to access it with the min cost, right? So which means
Why would
I
you
need to
return like
access.
you are returning node dot cost plus get min cost of child min cost, the line number 26.
Correct.
So what you are going trying to do there?
No, no, no. I'm not. So what I have to do is I have to assign it some variable here,
Okay.
so that I can actually compare here that variable. That's what I have to do.
You are trying to like do the operation when you reach at the leaf node.
Correct.
Yeah. Okay. So you have to like you should not return this. You should like run a variable like whichever thinking.
Correct, correct. So that's what, yeah, that's what I was saying. So int basically, for every um, every okay, got it. Okay, total cost, let's say. Okay, total cost, and you can actually say total cost equal to is plus equal to the node cost. Okay, and then you call the get min cost. So what
So
that means is the total cost, you add it, and then you have the total cost computed, and by the time you reach the leaf node, okay.
so actually this is a like local variable, so it will not go at in the last. Total cost is a
It
local
will,
variable for a particular function.
correct, correct. So what will happen is, what I'm thinking is, is yeah. So that's what I'm thinking. So maybe I should actually set it as an argument here,
Okay.
which keeps on adding either that, or so that I use a stack for adding the values,
Yeah, yeah.
right? And then like doing it. So which means I need to have a total cost as a
Argument.
parameter, and then you actually pass always this total cost in here. What that means is the total cost plus node cost, something like this here. So you pass always total cost plus node cost, something like this plus. You pass that. So what that means is like a running total.
Yeah, yeah,
You
yeah.
keep adding that running total, and then now when you reached it, so you have computed your total cost is the one which. So now if min cost is is greater than total cost, then you just assign the min cost, total cost. Basically, you're tracking the lowest
Yeah, yeah.
possible value
I
in
got it.
that. So this should compute it. The way to call this would be get minimum cost. Uh, get minimum cost of, you pass the root node here. You don't need this, and you pass the total cost as 0
Okay.
first initially, and min cost as dot min min value,
Okay.
the least value.
So okay, okay.
Yeah,
Yes.
sorry.
Do it all.
Oh, max value, sorry. Max value. So that it's always max, and then you assign the total cost to
Same.
whatever, whenever it actually comes.
Okay.
Now I agree. Like I see what you're nodding here. So here you should actually have min cost as a variable, and that should reflect in the min cost when it actually comes back, right? And you basically assign there, right? And you return the min cost
Okay.
here. That's what. So total value will be 0 initially when it's starting, and then when I'm adding it, the current node would actually get added,
Okay.
right?
So
And for every children, sorry.
yeah, I was like when the node becomes null, you are returning zero, but the function is a void
Yeah.
function. You should not return anything. The get
Oh
min
yeah,
cost,
sorry.
get
Return,
minimum cost.
return, return, return. Sorry, it was return. Sorry. So here it's zero. And one thing which I haven't done here is actually um, total cost plus equal to node dot cost. The reason is only if there is actually a children we do that. If there's not a children, then total cost. Oh no, 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 we don't need it. Sorry, we don't need it because I'm anyway adding it here
So
for every
what if
children.
what if you reached on the leaf? You are not adding the cost of leaf. Can you figure it out?
That's the one which I was thinking. You're right. Uh, First, initially thought the root I'm missing, but I'm not missing the root. But I'm actually one of the I was missing. So it was a leaf that I would be missing. So what that means is you call this again, right? And if I'm here, let's say like in 4, 5, 4, and 4 I'm actually coming in for the 4, this would be false, so you'll go on else, and you need to add that total cost of that particular node cost. So I need to add that for the leaf. So then I'm actually comparing it. Now it should take care of the leaf as well.
Get it? There's still some problem in your code. There is a bug in your code. Can you figure it out?
Yeah, yeah. Children, let's see. um Parent. Why do we need this parent? Do I need the parent?
I'm giving you 3 minutes to
Mm,
figure it out.
yeah, yeah. Uh, and let's run through this. So zero, you start with zero, and node equal to null. If it's not, it'll go children. It'll check if it's children. For each of the child, if there is a child, I'm iterating it, and then I'm actually adding the total node cost. Um, but I'm adding the child. The 5 will get added, called again, right? And that child will actually be the node, and its node cost is getting added. And then 4 will actually come. So then that we are actually covering it here, right? And then min cost. Okay. Min cost. Node. So when it starts 0, 3, 2, 1, so it will come 0, and then it actually has children 3. Now it will call 3. It added the cost of children, but now in for 3 it will call 2, and it can also call 0. So for 2, when it actually calls, the total cost would be 3, 0 plus 3 plus 2, right? And for 0,
Let me give you a hint.
it
It's
will be
related to
0 plus
the
2 plus 0.
min cost.
Min cost?
Yeah.
Okay. You mean the way I'm comparing? Okay. Um, or I can do one thing, like here, the min cost,
No,
I can
not
actually
not
replace it.
related to that. It's related to the way you are passing the value to min cost.
Yeah, so I mean it's going to be passed as value, so it will not reflect that. Is that your comment?
Yeah, yeah.
right? That's your point, right? So yeah, I can actually pass it as an integer object, and then I can have it as a, instead of like int, an integer object which will be passed as an, for example.
Like you have to do it like to keep the reference. Otherwise, it will be like a separate variable. Both will be the separate variables. You will
Yeah, yeah.
show the values
So
separately.
I mean, this is passed as a reference. If I do, and this would be new integer of that value. You can actually pass max value, right? And then here I have to compare dot int value, getting the integer compare, and you could, I believe this should be okay. Min cost assigning it should be fine.
Yeah, it looks okay
Um,
to me.
yeah, so now it's an object, but I was this I was kind of doubtful, but I was actually thinking if this logic is, if there is any flaw. That's
No,
what I
there's
was
no.
actually trying to.
Like I said that there's a bug in code, not the problem in logic.
Okay, not a logical issue. Okay, okay, I see. Okay, okay. So let me compile it.
Yes.
Is it okay?
Yeah,
Or
yeah.
you think anything else is left out here?
No, let's compile the code.
Okay, okay. Uh, it's not working, or is it working, or
You can try to run the code.
no? But the run test is not. Oh, run code. Okay, the run code I did it.
Yeah, that's the executing, not the test cases.
Yeah, I'm not having the test cases here. Is it a bug here, or is it like something wrong?
I'm not aware about that.
No, it's compiling fine, I think, right?
Yeah,
So
compilation is fine, but I don't know what. You can take some test cases.
right,
Maybe
let's actually kind of, what we can do is, as I do that, is it going to, first of all, okay, let's actually see if I can pass anything here. Let's see. Okay,
okay.
call that
Make a like
get cheapest.
try to pass
Um,
a null if it gives zero or not.
right,
You have to do the out system dot out. You have to print it, then it will get like
sure, sure.
reflected.
Um, let's see. Okay.
Yeah,
All right. Is it not working?
it's compiling. Let's see.
Hmm? Cannot find symbol. Uh,
You should keep this null in a node, like in a node. Then after you should pass that node. You can't pass like directly. You should make a node
no, no,
variable.
no. But that's not error.
What
But
error?
that's not error. No, no, I agree. What I'm saying is, it's actually saying
Yeah,
system dot out. Uh-huh.
I'm saying that you should try to do that. Like, I think that's the
Sure,
problem.
sure. You want me to actually create an object and then pass that as.
Yeah, then pass that
Uh,
object.
that doesn't seem to be the error, but I'll do what you're saying and then pass that node here. I believe that's what you meant. Is that right? That's what you meant, right?
Yeah, that's what I mean.
but it should not cause any difference. Yeah, let's see. Yeah, it's not, that's not an issue. It's system dot out. I believe that's the package that I have to actually add in Java. I believe. Is it right?
Try to
Is
remove
it?
the try to remove the plus. I don't know what the plus.
No, no, no. That's not issue. You can. That's it's. Is it not a string that I'm actually adding? Oh, I lost it. Or okay, I do. No, it's fine. It's correct. That's not a problem.
Okay.
But I think maybe like what you actually added, right? You added the imports. If you remember, but here it's there. It's there. I do see it. Um,
Actually, you're
I
returning minimum cost, or you should return minimum cost dot integer value. I'm asking, is it
yeah,
coming?
that's true. That's true. Yeah, I mean it is overloaded. I believe it's fine. Otherwise, it would have thrown an error. So
Okay.
that's not a problem.
I
So
have
I
no
mean,
idea about the Java syntax.
yeah, no, it should be fine. Int value, see, int value. This is correct. I mean, it doesn't matter. So otherwise, it will have thrown. Like if there is an int, it's overloaded. So it should work. What I'm thinking is, why is this not actually recognized? So something wrong. If you remember, like even the test case is actually not showing up. Something wrong in this. The way
Cannot see.
it is integrating. Maybe I should actually try it independently.
Do you need any like import for this, or
No,
is it?
here. That's what I'm saying. Here,
Yeah,
it's
it's
there.
yeah. There's like everything is imported like using a star.
Right, right. I mean that's what we do. It's basically all the packages, all the classes inside that package. System out package, all the classes inside that would be actually included. Should not be or deal something messed up. I mean, from an approach wise, you don't see an issue, right?
No, there's no issue in like logic.
Yeah,
I find that is
yeah. It's just that,
there is some bug in like the compiler. I think
yeah. Unfortunately,
they're also not providing the test cases.
yeah. I mean, typically it comes with test case, like run with test cases. This is actually not having anything at all. Is this? Should I refresh? Would it come?
No, I don't think it will like. Let's
Can
try.
you try at your side?
Yeah,
Refresh.
let me try. Let me try. There is like some problem with the.
Is it coming now for you?
No, no, it's not coming. Is it coming for the
Oh,
C++? Plus plus?
what?
Is it coming? I changed the language. Is it coming for the C++? Plus plus?
Yes, I'm. It's coming as C plus. Did it lose? Did I lose the changes?
No, it will not load this. Let me check.
No. If I switch to Java,
Yeah, it's like the same.
okay, the changes are there. Okay.
You can
Okay.
copy those. You can copy those test cases which are present in the C++ plus plus to use here.
Um. Okay. Oh, I see. It's there. Is it there?
I was asking from you. I haven't seen that.
No, it is not. There is no test cases here. So what I have to do is, so let me actually write my own test cases. Okay. So let's do that. So here you can actually say no dot. Is there are methods, right, for this?
Yeah, yeah.
No dot children, right, and no dot parent. So I have to basically construct this entire tree. At least like the first level tree will actually construct it. Okay. node dot, let's say uh, node dot children equal to new um, array of array, right? It's an array.